I'm Dr. Mahajan. Today I'm discussing the probability. The chapter name is a probability, and probability, all of you know that today all industries or all world depend on the probability. The probability definition is life is a school of probability. This British journalist write he life is a school of probability. In this chapter, the outline is introduction to probability, important items, types of probability, and associated rule. Introduction to probability. What is probability? Probability is nothing but the extent to which something is likely to happen. Right? The theory of probability is at bottom nothing but common sense reduced to calculus. What are the application of probability? You know that medicine is a science of uncertainty and an art of probability. Now, why probability? Suppose you toss this coin for 10 times. You will get either head or tail. So the combination are head, head, tail, head, head, tail, tail, head, head, head. It means 7 times head out of 10 times. Same thing, suppose the order are changed, tail, head, tail, tail, head, 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 tail, and so on. Here we see 6 times head out of 10 times, right? And so on. But is not that you expect 5 heads out of 10 since the coin is fair. So for any probability we are required two events, two terms, that is trial and event. So what is the trial and event? Tossing of a coin is a trial and getting head or tail is an event. For example, another example I consider here. Finding a playing card from a deck is a trial and getting a queen is an event. The experiment is known as a trial and the outcomes are known as events. Are you clear at this point? Suppose I throw two coins successfully two times. So what is the head and tail? So you think about this. An experiment is repeated under identical condition, does not give unique results, but may result in any one of the several possible outcomes. So what important terms are required for calculating the probability? The first is sample space. So what is the sample space? The collection of all possible outcomes of a trial. For example, all 6 dice of a die. Second, all 52 cards are bridge deck. Both the sides of coin, H and tail. This is the sample space. I am giving one example you. Suppose I throw two coin. So what is the sample space for two coin? You first to identify in one coin H and T and second coin H and T. So what are the combinations of possible here? So H H, H T, T H and T T. It means 4 types of combinations are possible. This combination is a sample space. Now the next definition is simple event. One outcome is called simple event. Example, in a deck of cards we picking a queen. So this is the simple event. And joint event, suppose two outcome simultaneously. Example, picking a coin, picking a queen of hearts, right? Equally likely event. Outcomes of a trial have same preference or chances. Example, in tossing a coin, head or tail are equally likely events, right? Now the next is impossible event. Example, club and diamond on same card. Okay. Now 2-3 terms also I have defined here. Important terms, that is intersection. Intersection, it means item from in both A and B. In according to diagram we check the red color is the intersection, and A union B in items from in A or B or both. You check the diagram. In the diagram the whole space is a union B and the common portion is a intersection B. The next definition is a complement of event. All items not from that event It means an universal we consider A in the universal, but remaining part is a dash. So that for event A, all event not in A, it is called A complement. Now the next definition is a mutually exclusive. Two events cannot occur together. Example, Queen of Diamond and Queen of Club not cannot occur together. Event A and B are mutually exclusive or disjoint. The next definition is, according to diagram also they show that A and B. The next diagram is mutually exclusive. All possible of events cover the entire sample space. This is called mutually exclusive. Example, for a six-phase diodes, the outcomes are 1, 2, 3, 4, 5, 6 are exhaustive and define S is equal to A union C. Here I am giving the example. You check in this example. I consider phase and not phase items. The red is 6 and not phase is 20, because you know that both card phase not phase are total 26. So the combination red and not phase is 26. Same is black and same the total are 12, that is 40, the total is 52. You check according to this diagram. Same I am consider in the case of queen and not queen. Hearts 1, not hearts 3, the total is 4, and for total cards consider 52 cards, so 12 is hearts and 36 is not heart, total is 48. In the case of queen there are 13 and 39 and 52. Now the one important definition is a permutation combination. All of you know that permutation is an arrangement of digits or letter. It is called permutation, and in the combination you can choose something from groups. That a group is called combination. You check the one example here in the ball. There are so many fruits are there. The fruit salad is a combination of kiwis, berries and bananas. We do not care what order the fruits are in. They could also be bananas, berries and peas, or peas, berries and banana, and etc. It is the same fruit salad, but in the combination case, the order combination to safe was 472. Now we do not care about the order. 74 would not work, not would 247. It has to exactly 472 factorial. This is the permutation. You also check according to this ABCD combination. The permutation is AB, SC, AD and so on, and combination AB, SC, AD. Right? So you check permutation is 12 and combinations are 6. Now, how to define it mathematically? So the definitions are: permutations are the possible ordered selection of R objects out of total of n object, and it is calculated according to the numerical formula NPR equal to n factorial upon n minus r factorial. And combinations are the possible selections of R items from a group of n items regardless of the order of selection, calculated as nr equals to ncr equals to r factorial upon r factorial n minus r factorial. Sorry, n factorial upon r factorial n minus r factorial. Here n is a total, r is a chosen. So we can write the formula n factorial upon r factorial n minus r factorial. Now we consider probability a quantity measure of uncertainty. It is a measure of strength of belief in the occurrence of an uncertainty event. It measures the degree of chance or likelihood of occurrence of an uncertain event. So we define the probability of an event A. So probability of event A equals to number of favorable occurrence for event A upon total number of possible cases. The some rules are required in a probability. How to rule applicable in probability? The first rule is range of values for PA. PA not greater than 1 and not greater than greater than 0 and not greater than 1. That is the range of values of PA. It means PA lies between 0 to 1. Sum of the probabilities of all mutually exclusive and exhaustive events is 1. So we can define PS equals to summation of PEI equal to 1. The third rule is complements, that is probability of not A. We can define PA dash. PA dash equal to 1 minus probability of A. In the fourth rule is intersection. Probability of both A and B. So P intersection A intersection B equal to N A intersection B upon N S. Here S is a sum, right? The next property is union. Probability of A or B or both. So P A union B equal to N P N A union B upon NS equals to PA plus PB minus PA intersection B. The next rule is mutually exclusive events. PA intersection B equals to 0, so that we substitute this value and find the PA union B equal to PA plus PB. So we are define here continuous table of probabilities. The probabilities continuous are according to this table. We can consider PD, PB, and also called as joint probability or simple probability. So their sum is total is 1 only. So you according to this tables you consider how to calculate the values. Now examples computing probabilities. In this example, event is red. The probability of red equal to number of red upon number of S. S is total sum. So number of red is total in the deck of 52 cards. 26 are red and total card is 52 to 1 by 2 event for red. But suppose I consider the event queen of hearts. So you know that queen and hearts also the deck is also considered as heart and queen. So we consider P hearts intersection Q. So 1 by 52 is possible. But I want to only hearts. So you know that in the deck of 52 cards, 13 are hearts. So we consider 13 upon 52 equal to 1 by 4. Same case we consider in the second part event queen. You know that in total 52 cards there are 4 queen is possible out of 52 cards. So 4 upon 52. And suppose I want to hearts and queen. So we consider the union because hearts how many possible and queen intersection is possible, that is 16 upon 52, that is 4 upon 32. Right. So the next definition is conditional probability. In the conditional probability example is some conditions is required. The probability of chocolate is 70%. This case is considered in the ice cream. You see the diagram. P chocolate is 70% and chocolate and strawberry is 35%. So what is the conditional probability? Conditional probability, because strawberry is depend on chocolate. So PA conditional B equal to PA intersection B upon PB. But it is known, you know that PB not equal to 0. This is the conditional probability example also explained in the conjugation table. You check the table, according to table we calculate the conditional probability. Now what is the relation of and or, and consider union, and in the set theory we consider intersection, and mathematical treatments are X. Same case in the union, right? Now rules of conditional probability. P A conditional B equal to P A intersection B upon PB. So you calculate according to given formula. Further, if events A and B are statistically independent, so how to calculate this value? PA intersection B equal to PA, PB intersection A equal to PB, and we substitute in this formula. So we can calculate PA intersection B equal to PA into PB. The next theorem is a Bayes theorem. What is the Bayes theorem? A method by which we might judge concerning the probability that an event has to happen in given circumstances upon supposition that we know nothing concerning it, but that under the same circumstances it has happened a certain number of times and failed a certain other number of times. This is called Bayes theorem. How to simplify how to understanding, we take one example here. Diagnostic cases, we often know that P. Probability of symptoms conditional to disease. The probability that you have the symptom given the disease, because this data has been collected from previous confirmed cases. So how to calculate the probability of disease condition to symptom? The probability of disease given the symptoms. So this is the example of Bayes theorem, and Bayes theorem used to reverse previously calculated probability based on the new information. According to decision tree diagram, you check how to calculate the Bayes theorem. The Bayes theorem interference is P A conditional B is a posterior probability equal to P B conditional A likelihood functions into PA prior probability, and upon PB is a marginal likelihood or normalized constant. The law of total probability and Bayes theorem. So this is the law of total probability and Bayes theorem. They are mentioned in the PPT. The law for total probability PA equal to PA intersection B plus PA intersection B dash. Same thing in terms of conditional probability. PA equal to PA intersection B plus PA intersection B dash. Okay. More generally, whereby make up partitions PA equal to, you can calculate according to this formula. Now we take example. Suppose in the stock market will go in the next year, that is the one event, it is called U, and event W economic will do well in the next year. So we check what is U is a stock market going in the next year, and what is W, economic will do well in the next year. So the conditional probability I am apply here, the data is given in front of us. PU conditional W 0.75, 0.30 and PW is 0.80. So we know that how to calculate PW dash, 1 minus 0.8, that is equal to 2. So we can apply the formula of Bayes theorem and simplify the values. The Bayes theorem is this, and according to this we calculate this. There are so many examples are given. One case also I am discussing a medical diagnosis problem. So how to diagnose the medical treatment, how to do the, this is symptoms of dengue or malaria or any disease. So this example explain how to calculate the medical diagnosis problems. So these problems you show everything, calculate, I am here, and substitute the value and find the total disease, and T represent test is negative or positive. So test is positive, you calculate according to formula and find the data and find the result. So this data we can represent according to decision tree. The decision tree is a very helpful for computer science person understanding what are the results are given. So with the help of this result we calculate the values. Now I summarize what today I am teaching. Introduction to probability. We have covered what is probability, application of probability, why learn probability. Second, I also explain important terms, trial and event, different types of events. And third, types of probability, simple, joint, conditional, rules and relation, and Bayes theorem. Thank you.